Hi everyone, I'm Yuezhong from University of New South Wales. Today I'm going to present my work that's AutoKey using Autoencoder to speed up gate-based key generation in body area networks. Recent research shows the potential of wearable devices to generate shared secret key by exploiting the gate biometric. In Figure 1, two devices measure the gate with accelerometers and quantize the gate signals to binary bits we call the key. When the two keys are the same, they can secure their communication. But in real scenario, the independent observations of the same gate biometric from different body locations do not match perfectly. In Figure 2, we can see there are dissimilarities between gate signals from different locations. After quantization, the dissimilarity will introduce many mismatched bits and results in unsuccessful pairing and slow down the key generation. So the motivation of the work is to remove the noise and improve the similarity of the observations from different body locations, and consequently to reduce the mismatched bits. The main contributions of our work are using autoencoder to predict the gate signal of one body locations by using gate signals from other body locations. By using the prediction to do key generation, we speed up the key generation by a factor of 1.9. We also proposed a transfer learning framework to reduce training data and the time. To remove the noise and improve the similarity, we use a neural networks called the denoising autoencoder. We consider the gate signal from chest as the ground truth, and the gate signals from other body locations are the corrupted gate signals by the noise caused from other body parts motions like leg and arm. When training, the autoencoder takes the corrupted version as input by solving the loss functions to minimize the mean square error between the output and the ground truth. The autoencoder will learn to discard the noise and generate a prediction of the ground truth. When we have trained model, we add a prediction step before quantization. Like in Figure 3, a device at other body locations needs to input its gate signal to the chain denoising autoencoder and get a predict ground truth, and use the prediction to generate keys. Since training is an overhead, we proposed a two-tier transfer learning framework to reduce the training data and the training time. A universal model is trained in the first tier called cloud training. The user retrain a universal model using its own data and devices in the second tier called edge training. We use a dataset of 15 subjects to do the evaluation. We train models that use acceleration observed at other body locations to predict gate ground truth at the chest. Here we can see the signals. The blue curves are the ground truths from chest. The green curves are the corrupted versions from other body locations. The red curves are the predicted ground truths by the green curves. We can see the red and the blue curves are much more similar with each other. Then we do the key generation. We use two measurements. Bit agreement rate represents the percentage of the bits matching the keys. The key generation rate represents the number of keys generated per minute. We can see in Figure 5, compared to using the corrupted signal, using predict ground truth significantly improve the bit agreement rate and the key generation rate. We also collect an in-house data of 6 subjects to evaluate the transfer learning framework. We can see in the table, the baseline is training a model from scratch using all data. Compared to baseline transfer learning can save 50% of the training data and 88% of the training time. We also collect data and do a security analysis of 3 attacks: passive attacks, mimicking attack, and a video session attack. In Figure 5, we can see all the attacks can only reach around 62% of bit agreement rate. That is much lower than the legitimate devices. And in the whole security analysis, all attackers fail to produce any successful key pairing with legitimate devices. Thank you for listening. I would like to take any question.